In this lesson, we'll use an imported point map containing stress data to drive a variable shell and gyroid infill for a bracket. Let's start by importing the bracket that you downloaded below. Opening your File Explorer, you can pull the part file into your notebook. I'll use the hotkey Z to zoom to fit, and I'll double-click on this body, right-click, and convert to an implicit body. I'll rename this implicit body Implicit, and I'll name the section Geometry. Next, I'll want to import my stress data. I'll add a new section and call it Field from Stress Data. This is where we'll create our field that we'll use to ramp our wall thickness. In the Fields tab of our ribbon, under Utilities, I'll choose Import Scalar Point Map. We'll open our file path and add our CSV file. Note that the first, second, and third columns in this file denote the X, Y, and Z locations of each point. The fourth column contains the stress data. I'll add my units and set my scale, 1 Pascal. Once our import is complete, I'll isolate this block and zoom in where I can see our stresses at each discrete location. Next, under our field utilities, I'll add a field from point map block. I'll drag our point map in, add a barycentric interpolation, and no extrapolation. Now, I'll turn off all visibilities and use the hotkey F to view our field. In the field viewer, I'll change our color map to turbo. And now we can see a better representation of our stress field. If I want to smoothen my field to make these transitions more gradual, I can add a block called Smoothen Field. This can also be found in the Utilities under your Fields tab. Viewing this smooth field, I see that we've now established a more gradual transition. I'll right-click, make this a variable, and call it Stress Field. I'll collapse our two sections and add a new section called Varying Thickness. The first thing I'll want to do is create a shell from this part with varying thickness. I want to reinforce the shell at the areas of highest stress. I can double-click and add a ramp block. Our scalar field for this ramp block will be our stress field that we created. And I'll want to set my in-min and in-max as the minimum and maximum values from our point map. I can open up our point map, view its properties, and I see that we have this list of scalar values. What I can do is add a math block called max and min to each of these in-min and in-max values. I'll use this arrow to change the overload to a scalar list for both. And now I can add our scalar list values. From our point map, I'll pull in our values. And in the upper right corners of either of these blocks, we see our minimum and maximum imported values. I want our outmin to be the thinnest portion of our shell. I'll make this 2 millimeters, assigning it a negative value since we want to shell inward. I'll make our outmax negative 20 millimeters so that we have a 20 millimeter thick shell anywhere we approach our maximum value. I'll add a geometric continuity, and I'll right-click and make this ramp a variable called shell ramp. Next, I'll add an offset body block. And for our body, I'll double-click and add our implicit bracket. And our distance will be the shell ramp that we created. If I isolate using the hotkey I and zoom to fit using Z, I see that this is our body with that variable shell removed. To isolate the shell, I'll add a Boolean subtract block. And I'll make our primary body our implicit, and our subtraction body this offset body. If I isolate this Boolean subtract using the hotkey I, and section cut using X, I'll adjust our normal, and we can view this variable shell thickness. If I view this in relation to our point map, I see that we have the thickest shells near the areas of the highest stresses. I'll right-click and make this a variable called varying shell. Now, let's follow a similar process to vary the wall thickness of a gyroid infill. I'll make a copy of this ramp using the duplicate variable option, and I'll drag it to the bottom of our notebook and rename it to gyroid ramp. At this minimum stress value, I'll make our gyroid 1 millimeter thick, and at the maximum stresses, I'll make it 20 millimeters thick. Next, I'll add a block called Infill Gyroid, where I'll use my gyroid ramp as our thickness. The body will be our initial implicit body, and we'll set a cell size of 10 by 10 by 10 millimeters. If I isolate this infill using the hotkey I see that we have this gyroid with thicker walls at the higher stresses. Finally, I can add a Boolean union block, and I'll union our infill with our variable shell. I can make this gyroid infill a variable, and I'll call it gyroid. If I add a blend radius to our Boolean union, I see that we get some extra material buildup on the outside of our part, so it's good practice to add a Boolean intersect block, where we can intersect our Boolean union with our initial design space, our implicit body. I'll isolate this final part and section cut to view our results. Now we see that we have a gyroid infilled bracket with wall and shell reinforcements at the areas of the highest stress. I'll right-click, make this a variable, and call it Final Body. To view in high resolution, I'll use Ctrl-H on my keyboard, where we can view the final results of our part.